Hey you guys, this is Mr. Sal. Thanks for watching. We're going to look at those special angle relationships that we talked about last time, but now the transversal is going through two parallel lines like you see in this diagram. So thanks for watching. Please comment, subscribe, and give us a like. Thank you. Unit 13, number 2, classwork. As long as you guys understand all the stuff that we learned from last time, alternate interior ankles, alternate exterior ankles, corresponding ankles, vertical ankles, straight ankles. Seems like I'm missing one, but it doesn't really matter.
Corresponding ankles?
Sure, corresponding, whatever. Alright, all of those. Then the rest of this stuff today should go pretty smoothly. Use the picture given below to describe what parallel lines are. Parallel lines are lines that will go on forever and never touch each other, okay, or intersect. Whichever way you prefer to say it. Use the correct notation to denote that line L is parallel to line M. Yes, let us do that. So we have line L, and we usually do this in lowercase letters or cursive like these. Line L is parallel to line M. So this would be a way that we write it, shorthand way, instead of actually having to write out all the words. Line L parallel to line M. It is possible to annote the lines as well. Usually they'll have some kind of red arrow on them extra on the sides like this to indicate that they are parallel as well. Draw a transversal for the two parallel lines above and label it line T. Label the angles formed by the transversal and the parallel lines with numbers 1 through, that should be 1 through 8. Be sure to number the same, we'll just number them together, alright? If you want to follow along, that would be great. If not, do it anyways. Alright, so I'm going to make this line T right here. So that gives us a good, put some arrows on that. Line T labeled as they wanted it. And then let us label the ankles. Alright, transversals intersect. Two or more parallel lines create ankle pairs that have special properties, which we will see. Use what you know about rigid motions, which are transformations, right, to discover some of these relationships. Rigid motions are rotations, reflections, and translations. And if we remember correctly, not that anyone usually does, but those maintain congruency, which we will see. Right here. So, for example, what type of ankle pair is, let's look at ankle 2 and ankle 6. Yes, these are corresponding ankles. All right, let's go ahead and copy ankle 2 on a piece of tracing paper. Well, I'm just going to do it on the iPad. Then we'll describe the rigid motion that will carry ankle 2 to ankle 6 and determine the relationship between ankle 2 and 6. That sounds great. Alright, now that we got that taken care of, for example, ankle 2 in green at the top here, I can translate it downwards and then to the left, and it gives me ankle 6. If I drawn that better, we could see that they are the same ankle, just as if I were to take ankle 6 right here and translate it a little bit to the right and then up. Then it gives me ankle 2 as well. So, describe the rigid motion. This one is just a translation. And the relationship between these two, we can see right here that they are congruent. Use a similar process to see if the same outcome holds true for all the corresponding ankles in the figure. Start by listing the remaining parts of the corresponding ankles and then state the relationship. That sounds great. Alright, so we can see ankle 1 and ankle 5 are corresponding. Let's see if we can translate these. Alright, so if I took ankle 1 and I went down and then slid it down the slide right here, we can see that it is also like ankle 5, so that's correct. But not only these, but if I took it and then rotated it as well, we should be able to see, if I can get this right, that the vertical ankle right here is correct. And if I slid this down into 8, then it is also the same as well. Nice. So those corresponding ankles work as well. It's pretty nice. So did it hold for the other ones? Yeah, it did. It did. All right, let us list all of the vertical ankles also. So for example, let's start with this ankle 2. Ankle 2 and ankle 3 are vertical. And we should be able to remember from last time, all vertical ankles are congruent. We can demonstrate that right now. All right, just as a real quick side note on these, let's look at those two ankles. So ankles 2 and 3 here are congruent. Here's why, because ankles 1 and 2 give us a straight ankle relationship. In 7th grade you called it supplementary ankles. But 1 and 3 are also supplementary as well. So 1 is always going to be the same right here. And since 2 and 3 have to make up the difference for each set of supplementariness, they have to be the same as well. We could show it algebraically, but I'm afraid it would confuse more people. Okay. All right, so back to the listings up in here. As we got ankle 1 and ankle 4. Those are also congruent and vertical. And then we also have ankle 5 and 8 right here. Just remember, vertical ankles are through the vertices, so 6 and 7, they are across the vertices from each other. So ankle 6 is congruent to ankle 7. Continue to use rigid motions and what you know about vertical ankles to discover other relationships that exist between alternate interior ankles and alternate exterior ankles. Be sure to provide justification for your claims. Let us proceed. All right. So here's what we know is that the vertical ankles are congruent, right? Yeah. But we can also see, based on what we had done before with the translation stuff, like ankle 2 right here is also the same as ankle 6. Okay, now this is only going to be true for parallel lines, not like last time where they were not parallel all the time. And since these are now parallel, we can see that these corresponding ankles, these are going to be congruent. So what that means is if I took ankle 2 and said maybe it's 65 degrees, then ankle 6 also would be 65 degrees. Now those are corresponding ankles. What's the relationship between ankles 3 and 6? Wasn't this the bellwork one? They're alternate interior, very good. But 3 is also congruent to ankle 2. And that means that these two alternate interior ankles are also congruent. And ankle 7 is congruent to ankle 6 because they're vertical. And what's the relationship between 2 and 7? Alternate exterior ankles. And we can see, because of all the congruentness, that ankles 2 and 7 are also congruent. This congruent relationship of corresponding ankles and alternate interior ankles and alternate exterior ankles goes away as soon as lines L and M are not parallel. So let's consider the other relationships, okay, like ankle 1. Ankle 1 and ankle 4 are congruent. But if we were to use a translation, we could translate ankle 1 onto ankle 5, and 5 is congruent to 8. So we kind of color-coded these. This one should be green, though. Green, green, and green. There we go. Complete the following statements in the box below. If two parallel lines are intersected by a transversal, corresponding ankles are congruent. Yeah, very good. Congruent. We had already seen that one right there. But alternate interior ankles are very good. And then finally, alternate exterior ankles are also congruent. Very good. So yeah, the same answer for all three parts. Of course, we already knew that vertical ankles were congruent too. That's nice. In the diagram below, one ankle measure is given, which is all we need to find all of the other 7 ankle measures. Find the measure of each remaining ankle if line L is parallel to line M. But we do need to know that line L is parallel to line M, so it's good that they said that. So to start us off, I know that this ankle radical, 110 degrees, and automatically the vertical ankle is going to be congruent to it, so ankle 1 also 110 degrees. But based on what we just learned, looking at this 110 degree ankle, ankle 5 is alternate interior with it, so it also is 110 degrees. And ankle 8 is vertical with ankle 5, so it also is 110 degrees. All right, next up is we'll start with ankle 2 because that's next on the list, radical. But ankle 2 is in a supplementary relationship with that 110 degree ankle. So to find it, we're going to take 180 degrees, or the straight ankles, and subtract the one ankle that we have, 110, and that gives us 70 degrees for ankle 2. Well, from here we can see that ankle 3 is vertical with ankle 2. Ankle 6 is alternate interior with ankle 3 or corresponding with ankle 2. And ankle 7 is vertical with ankle 6. So all of those are 70 degrees as well. Number 10, line F is parallel to line G and one ankle measure is given in the diagram. That's all we need to find the missing ankle measures on these. So we can start off with ankle 1 if we want, but let's acknowledge this 55 degree ankle. Ankle 2 has to be congruent because it's vertical, so we'll just fill that in. And then ankle 5 is corresponding with that 55 degree ankle also. So it also is 55 degrees. And then finally ankle 7 is vertical with ankle 5, so that also is 55 degrees. Next up is, we can find ankle 1 radical. So it is on that straight line again. And we know this one radical is 55 degrees. So we're going to take the 180 and subtract the 55 degrees. So we get 125 degrees for ankle 1. See, now we can see radical, the ankle 1 plus the 55 degree ankle is 180 degrees, which is what it must be in order to create a straight line. Well, from radical, ankle 3 is vertical with ankle 1, so it's 125 degrees. Ankle 8 is alternate exterior with ankle 1, so it also is 125 degrees. And then finally, ankle 6 is corresponding with ankle 1, so it also is 125 degrees. For 11, lines L and M are parallel. We'll solve for X and for the missing ankles, and we'll write those ankle measures on the picture. That sounds great. All right, so here's what we know, and let's just identify the ankles. This is a right ankle, so this one is a right ankle, and its corresponding ankle is right, and so is its alternate interior. Now, since these are 90 degrees, we're going to take 180 and subtract those 90 degrees, and that will give us this ankle, which also is 90 degrees. So its vertical ankle is 90 degrees, its corresponding ankle is 90 degrees, and its vertical ankle from that one is 90 degrees also. So all these ankles are 90 degrees, which is great, but we can see down radical that that's a 90 degree ankle, which is equal to the 2x plus 10. So now we've got all the ankles ready to go. We just need to solve for x. So from radical, we'll subtract 10 from both sides. And radical, we will divide both sides by 2. Yep, and x is 40. So x is 40. All right, to start this one off, we got the 75 degree ankle, and it is alternate interior with this ankle, so they are the same, which will allow us to solve for x. But let's identify these other ankles as well. We know this is 75 degrees. This one's vertical with it, this one's corresponding with that 75-degree angle. So all these are 75 degrees. Now this makes a straight angle relationship with this one. So we can take that straight line 180 degrees, subtract the 75 degrees we know, and we can see that angle is 105 degrees. So that means its vertical angle and its corresponding angle is congruent, and same with its alternate exterior angle. All of these are congruent and are 105 degrees. So now that we have that, we should be able to solve for x. So we're looking at this 11x minus 2, and that would be equal to 75 degrees. So to solve this, we're going to add 2 to both sides. And from radical, all we must do is divide both sides by 11. Oh yeah, x is 2, right? No, x is 7. Yeah, very good. X is 7. 77 divided by 11 is 7. That's good. And that's all we needed on this problem. All right, C, on this one, these two angles, their relationship is alternate exterior. And since line L and M are parallel, they should be congruent. And same with their vertical angles. Now, they didn't tell us what these ankle measures are, but what we do know is that they're equal to each other. So we can write these out as one equation where 14x minus 1 equals 12x plus 17. And from radical, we would just solve this equation. So I add 1 to both sides. And then I would subtract 12x from both sides. And then finally divide both sides by 2. And I get x is 9. Now that just tells us the value of x. It does not help us, or it does help us to determine the ankles, which we do not have yet. So to solve for the ankle, I'm going to use the 14x minus 1 stuff. But now I know that x is 9, so I'm going to replace it with 9. Multiply these, and then 126 minus 1 is 125 degrees. So all the ankles here are 125 degrees. And we can confirm it with the 12x plus 17 also. So again, I would go back into that, replace the x with 9, and I can see it also is 125 degrees. Now that should help us to find these other ankles also. These ones that we have not found yet, radical. But we can solve for those easily. This angle would be 180 degrees minus the 125. And this gives us 55 degrees radical, which means all the other ones are also in orange there are 55 degrees. So that 180 degree ankle is coming from, you could either look at it like this one. This is 180 degrees. This one's 125. So this one has to be the rest of it 55 degrees. All right, D here is similar to the last one where we got to solve for x before we find our ankles. So yeah, let's identify though first, right? We got this ankle, and then this one, and this one, and this one. These are all congruent. So these other ones also have to be congruent. So we got the red and purples. And 21x plus 5 must equal 23x minus 5. So we'll set that up. And we'll just continue by solving this. So I'll start by subtracting 5 from both sides. Actually, make that add 5 to both sides. That'd be a little bit better. There we go, that's better. And then we would subtract 21x from both sides. And then finally divide both sides by 2. And we got x is 5. So now that we know what x is, 5, we should be able to solve for those other ankles. Let's start with one of them. I'm going to start with 23x minus 5. And I will go ahead and replace the x with 5. And solve this. So yeah, we get 110 degrees for this ankle, which means those other 3 red ones must be 110 as well. And if these are 110, then to solve for the purple ones, we'll take 180 and subtract the 110, leaving us with 70 degrees, which we've seen already. So those purple ones are 70 degrees. Given two lines, J and K, in a picture below with transversal L, devise a strategy to determine whether the two lines are parallel using what you know about the properties of rigid motions. Also use your strategy to determine whether lines D and E are parallel. Stating that the lines do not look parallel is not a justification. So they're going to do this to you guys. They're going to make them look not parallel, but we have to be able to determine if they are based on the ankle relationships which we have just discovered. So, for example, if we were to look at this ankle, if it were different than this one, right? Now what's the relationship between that red and purple one? Those are alternate exterior ankles. And if the lines are parallel, then they have to be the same. But in this case, with the different markings, they are not the same, so we could say J and K are not parallel. Another way that we might see this is they'll give you the ankle, something like this one, maybe it's 130 degrees, and then maybe this one is 130.2 degrees. These also are not parallel lines because those two ankles are not the same. We can make a small change, and now we know that the two corresponding ankles are congruent. So lines J and K now would be parallel. But like I said, they'll do it on a diagram like this one right here. They'll give you this, and we could say, well, D and E, they don't look like they're parallel, but then they'll do something funky like this. This is 70 degrees, which we've just seen, and then this one is also 70 degrees. Okay, so they just don't look parallel, but they would be in actuality.
Why would they be parallel?
Because now we have a special anchor relationship, alternate exterior ankles, that are congruent. Now we could move that 70 degrees though, and maybe instead of alternate exteriors, they did it with corresponding ankles. That's okay too. These would still be parallel lines. So number 13, given two lines, if a transversal cuts through both lines so that corresponding ankles are blank, then the two lines are blank. Okay, let's fill those in. So yeah, the two corresponding angles are congruent, then the two lines are parallel. Determine whether these following sets of lines are parallel or not. Provide a justification for the response. We will. Is P parallel to Q? Why or why not? That's very good.
Yes.
These two are alternate exterior, and they are congruent, so the two lines must be parallel. So on this one, we got to be extremely careful because there is no relationship between that 86-degree angle and the 91-degree angle. What we got to do is find some kind of relationship between the two. For example, I could find this angle right here, which is corresponding with the 91-degree angle, and just see if they're the same. So to do that, this is on a straight line right here, which means they should add up to 180. We know the one here is 86 degrees, so we'll subtract that out. And when we do, we get 94 degrees, which is not the same as this 91-degree angle. So these would not be parallel.